Yeah. Now, we'll talk about when the associative property works and when it doesn't work, because it's one of those things where it's like it doesn't work all the time, and that's okay. I don't work all the time either, right? So why should the associative property have to? I don't have good jokes, okay? I only have really cringy jokes. It's great. Alright, so you know what? I'm gonna straight up, I struggle with spelling. Most of you know that about me. Teaching on Saturdays says otherwise. Okay, maybe I work a lot of the time. Merp. But I'm a Mike Kinney, okay? What do you want from me? If I'm not doing 5 things at once, what am I doing? I'm going to look in my book to spell the associative property, because sometimes we all need a little bit of help, now don't we? Oh, it's turning on me. Oh, I'm falling. Oh, we're doing great, aren't we? Associative property. It's all about who you associate with. Ah ha ha. Ah ha ha. Just clean that up a little bit. There we go. Doing great. There we go. Doing great. We're doing difficulty there for a bit. Today, don't worry, you're just starting at the beginning of the lesson. We were just talking for a bit beforehand. Okay? So today we're talking about the associative property, the distributive property, and the commutative property. And we're hopefully going to talk about some things on... words are hard today. Words are hard every day, but you know. We're going to talk about some ways that you can remember them. Because I don't know about you, but I struggle to remember what stuff means sometimes. So we got to find fun ways around it. And I'm teaching on a Saturday because I teach every other day of the week too, except for Sundays. So, you know, this is the day I have free to do this. Also, this is when most people wouldn't be in school otherwise. So if they need extra help, this is a good time for it. Also, I'm just trying to vicariously feel like Bill Nye the Science Guy and teach you on a Saturday morning. All right. So when I think associative, I think of the word associate. Does anyone know what the word associate means? What does the word associate mean? If I'm associating with someone. It's okay if you don't. Just wondering if anyone does. To relate to someone. Nice. If I'm associates, to correlate with someone. I love that. To be closely tied to. Ooh, I like that one. To relate. Oh, I'm loving it. Making a connection. Ooh, that was a good one. These are also good. You talk to them. I love that. Yeah, if you're associating with someone, you're talking to them. These are beautiful. Hold on to these thoughts. Those are all so beautiful, and you're all so right. That's what it means when you yourself associate with someone. So when we're talking about numbers associating with each other, we mean these numbers are interacting with each other. It's how they're interacting with each other. They are associating with each other. Now, the associative property is saying that for some things, it doesn't matter the order in which they associate. We'll still get the same answer. It doesn't matter the order in which they interact. Okay? So let's do an example of that. Yeah, I looked at an example and I was like, no, it's not right. Yep, that's right. Okay, so here's the associative property. Let's say I have... I don't know, 5 plus 6 plus 1. Okay? Now, what the associative property is telling me is that it doesn't matter if I pair these like this, right? The parentheses in our order of operations means that we do that first. It doesn't matter if I do 5 plus 6 first, or if I associate them differently. right? This is going to be the same answer. It doesn't matter which pair I associate first. I can pair up 5 and 6 and go, hey, you two interact first, okay? You guys are interacting. That's going to be the same as if I said, you know what, 6 and 1, actually you're going to interact first. It's the same thing, right? Because I do 5 plus 6. Let's prove it to ourselves. Let's prove it. 5 and 6 are dating now, confirmed. Yeah, listen, like, it's the same thing. The relationships they build together. You guys are funny. So if I pair up 5 and 6 first, I associate them together first, right? I'm going to get 11. Sick. And then I do plus 1, and that'll get me 12. All right, let's see if we got the same thing on the other side when I associated them differently. When I paired them up differently. When it's now a shipping class, listen, I am all about that in math class. Because honestly, our numbers and our rules in math are often about the relationships in which different numbers have with each other. So I'm okay with us getting extra and shipping our numbers, right? I'm okay with that. So in this situation, if I associated them differently, if I went, you know what, I'm not so much into the 5 plus 6 fandom. I'm more into a 6 plus 1, right? And then 5 is the tag along, right? That's what I'm into. Let's see if we still get the same answer. 6 plus 1 is 7. I still have to add 5 though, right? We're not cutting 5 out. They're just the third wheel now. Hey, my gosh, I still got 12. The associative property worked. It doesn't matter who I ship with who when it's addition. It's still going to work. Now, we can do the same thing. The same shipping rules apply. It is a poly relationship. The same shipping rules apply. The same associative rules apply for multiplication. Okay? So let's take a look at those really quick. Oh, thank you for the coffee, honey. So the same rules apply if I'm doing that with multiplication. I can still do that. So let's use the same example. I've got 5. I'm going to use the dots for multiplication because this is going to be an algebra course, so we're going to be using X for a lot of things. Listen, it's all about relationships, and sometimes our X's are involved, and it's going to be okay. We'll get through it together, okay? I only have bad jokes. So I've got 5 times 6, let's say, times 1. Now, also, please note that I'm not actually changing the order in which I'm writing these, right? We went 5, 6, 1, 5, 6, 1. Here, again, it's 5, 6, 1, 5, 6, 1. All that I'm changing for this example, I just threw my marker, is how I associate them or how I ship them. Okay, so here I'm going to associate or ship 5 and 6 first, and 1 is going to be, the third party that comes along later. And over here I'm going to go, I'm really more into the 6 times 1 fandom. I ship 6 times 1, and I think 5's just the friend there. Let's see if we get the same answer, okay? Let's see if it ends up being the same. So we've got 5 times 6. That is going to give me 30 all day. Hey, that's the same age as me. Times 1. 30 times 1 is 30. Cool. All right, let's do the other side. I'm now going, I'm not into 5 times 6. That's not my ship of choice. Let's do 6 times 1. I am loving this example. 6 times 1 gives me 6. And now I've got to multiply it by 5. My gosh, I got 30 again. That means that the ships are equivalent. I can associate them either way, and it's going to work. That's the associative property. That's all she wrote. All right, we can do a few more examples. And then I want to show you when it doesn't work. Because I think we all know. Thank you for the donut. Ooh, there's a Minneapolis con in May. I'll look into it. I'm probably going to be at cons this summer. Because as someone who is actually a teacher, I really have to keep in mind the safety of my students. And that I am at risk for being a high spreader of COVID-19 because I work so closely with so many people. So probably going to be visiting cons more this summer, hopefully. And I will also let you guys know when I'm planning on doing that. But yeah. So here's what we're doing. Oh, just a second. Looks like we got to get rid of somebody. Okay, bye, buddy. All right, cool. What was I talking about? Oh, what can you use this for in algebra? Honey, this is that's such a good question. Such a good question. Because here's the thing. We get taught these properties, right? And we're like, that's great, but why? Think of these properties. Think of them, here's going to be a weird metaphor. Think of Legos. Think of Legos for me. Think of the Millennium Falcon Lego set, right? And we're putting apart from each other. It's like, yeah, that's a cool Lego, right? It's neat. But all of these different rules together are just building blocks that together make the really, 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 really cool thing at the end. So when you're going to be using this in algebra, you are going to be using it constantly, okay? This is one of those properties that's there that when you understand it, it's just something that you get to play around with. Because at the end of the day, once you learn all of these different building blocks, you get to play around with them. And while you can use it to make that cool Millennium Falcon, you can also take all of those pieces and build something really cool and new that no one's ever thought of before. And that's the really crazy, neat part about math, is that every single day, we are taking these parts. Mathematicians' jobs are to take these parts and build cool new stuff for us. And that cool new stuff looks like what we're doing right now. You get to see my face on your telephone. You could be across the world right now, and we're connecting with each other. That's mathematics. That's what it is. I want you to take a moment all around you today and look at all the different math you have, okay? From buildings to our technology, everything. Math is that unsung hero right at the bottom that builds it all up to make it all work. Geometry too. It's all there. And we like to think of these subjects as separate, right? And we like to separate them into different books and all to help you learn them. But that's really just us taking the big whole thing of mathematics and cutting it up into little pieces so it's easier to digest. But really, it's all one big thing. It's one big breathing, artistic organism, right? It's honestly an art form. It's just what we're learning right now are those little tools. And I think that's really neat. I always tell my students, like, look, do I look like someone who likes boring things? And they're always like, no, you don't look like you like boring things. And I'm like, yeah, because I don't like boring things. All right? I like cool, interesting things that get crazy. And that's what math is. It's this crazy cool thing. We can use it for really boring stuff, right? We can use it for stuff that we hate to do. I hate doing my taxes too, okay? I I don't like it, it's not fun. But we can also use it to make super cool stuff. I use it when I make my cosplays. I use it when I sew. I use it when I make things. It's such a cool tool. How do you get better at math? Practice, 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 my dear. And also take the shame out of it. It's okay to learn at your own pace. It's okay to not get it as fast as the other person. It's okay to have dyscalculia and have to learn your way around where your brain maybe doesn't function the same as someone else's. I'm dyslexic. I have to learn my way around a lot of stuff, but I don't let that stop me from writing because I love to write. Okay? Move at your own pace. Find your own way. You're perfectly capable, and if you don't get it one way, that's okay. You can find another way, and I believe in you. I hope that helps. All right, where were we at? Let's get back to learning about mathematics. All right. Oh, honeys, don't interact with the trolls. Just ignore them. They feed off of it, okay? If you ignore them, you take away their power. Because that's all they're here for, is just that little bit of attention. And they just can't handle that the attention's on me right now. It's okay. Focus on yourself. Focus on having a good time. I'm glad you're here. And I hope the trolls pick up a little bit of mathematics while they're here as well. Also, it's really cute. I think it's so funny. I just think it's, just a side moment on this. I think it's so funny when teenagers on the internet try to troll me or make fun of me. I think that's so funny. Like, I'm 30 years old. I don't think you call it bullying at this point. Right? I just think it's like, listen, my students are way more creative than you. You've got nothing. That's funny. Okay. You guys are fun. Aw, you guys are sweet. Okay, so we talked about this. I'm now going to write it down in a generic way for us, okay? I'm going to write it down in that generic way for us so that we can kind of have that for our notes, okay? But I like to start with the real example before we get there. Burp, burp, burp. So that was the example on what it is and how it works. Here is the rule, okay? Ran out of room, sorry. That's a parenthesis, that's a parenthesis. Right? It doesn't matter how I group these. It doesn't matter how I ship them. They're still going to be equal to each other. And then we can do this also for multiplication, right? There you are. Also, this does not work for subtraction and division though, okay? So I'm going to write in red for this one. It's only for multiplication and addition. And the reason for that is that the subtraction plays with our negatives, and so we can get a different thing if we do those in a different order. Similarly, our division is all about how we cut things up. And so it doesn't work. Yeah, that's times C. This is a C. But there's parentheses. Okay, so not for division or subtraction. Cool. I'll give you guys, I know some of you like to take notes, so I'll give you a moment to write that down. And then we're going to move on to the commutative property. I like, you doing math in pen? I too like to live dangerously. Have a good day, my dear. All right. Does anyone need a little bit more time to get that down, my dears? Aw. Well, I'm glad I'm helping you enjoy math just a little bit more, my dears. All right. We're now going to talk about the commutative property. Woo! Yeah, commutative. All right. Also, like, thank you to the person that got me the new erasers and pens for this. Like, you're a real one. Thank you. Ooh, look at how smooth that is. Erases almost as well as my husband. I have bad jokes. The eraser's gonna get jealous. Oh, why am I like this? Okay. Anywho. All right, we're talking about the commutative property now. Again, I'm gonna look at the page to spell it because I can't spell. Yay! That's okay, using our resources, right? Using our frickin' resources is so good. This is gonna move on me. Don't move. Stay in place. I believe in you, board. All right. Now here is my first question, my loves, my dears, my wonderful listeners. What word do we see in the word commutative? Do we see a word? That's okay. Have a good day. Community. Ooh, I like that one. Comment. Communicate. Commute was the one I was looking for. I love that we got so many, though. That makes me very happy. Active. Oh, we could spell it with... You guys are so creative. You guys are better at Boggle than me. All right. So the word that I was looking for, and that I see, and that's going to help us with this, is commute. It would need an E there, right? But like, commute. What do we do when we commute somewhere? If I'm like on my daily commute. Communism. Okay, now I feel like I'm back in my classroom. Yep. Travel. Awesome. If I'm commuting somewhere, going somewhere, moving. Yes. Not tax fraud. Walk, move, train station. I love it. Going somewhere. Going from point A to point B. Yes, these are such beautiful ways of saying that, my dears. Awesome. Think about that. That's going to help you with this one. Okay? The airport. Yes, running. I love it. No, not sparkly tax fraud. Going. Oh, you guys are delightful. I just need you to know that. Is there any other kind? Okay. So yes, aggressive walking. Walking and gay, right? I may have told one of my friends this morning that I was like, listen, I'm gonna need you to move at a gay pace, okay? We're gonna have to keep moving. All Might's car. No, I think you're thinking about my car. I drive too fast. Speed walking. Yes, it's going. It's moving, right? I always tell my students when I teach this one in class, I was at home and I commuted to work. I was there, now I'm here, but I haven't changed at all, right? I'm still me. So here's how the commutative property works, okay? All right, so if I have, I don't know, we'll do 6 plus 5 again. No, we'll do a different one. 6 plus 2. I don't know. If I have 6 plus 2, what I'm saying with the commutative property is that I can take 6 and I can commute it to a different part of my equation. I can move it around. I can move it. Right? So I could write this as 2 plus 6. See what I did there? They flipped places. In my last one, they didn't move, right? It was just how I shipped them. It was just how I associated them. Here, I moved it. I moved it, right? But does my answer change? Does my answer change? No. Let's see. Let's prove it, shall we? Let's prove it. So I have 6 plus 2. That gives me 8. Ho, ho, ho. And I saw you guys saying that earlier. What's 2 plus 6 then? I think it's still 8. It doesn't change. Nice. It is also 8. That's all the commutative property is saying. Scoots around. That's all it's saying, is that I can go here to here and it does not change. I can move it. It is witchcraft. I always tell my students when they're like, what are we doing in class today? I'm like, we're doing witchcraft. My voice is cracking a lot today. That's fun. Who said 7? It's okay. Happens to the best of us. My students recently watched me in class, add 5 plus 1 wrong. And I'm like, wow, we're having a day. Happens to the best of us. Don't get hung up on it. Okay. So, I don't know, 21? It's the difference between ship names. Yes! It doesn't matter the order in which you say the ship name, right? You put their names, they're still together. I love that. That is hilarious. I like how we've taken this and we've changed it to ships. Thank you for the finger arts, love. Oh, that's good. All right, so similarly to the last one, this only works with addition and multiplication. So let's do a multiplication example. Yeah, Shinikami versus, I don't know the other one. But like if you did Kami Shimi, we'd still be like, yeah, that's Shinso and Kaminari. We know that, right? if they wanted to switch me and my husband's ship name around, Eraser Mike to, I don't know, maybe put me first for once, Mike Eraser, it'd still be the same thing. Oh gosh, that's silly. All right, second example. Oh, I'm getting hair in my mouth. We're doing great. All right, so I can similarly do 6 times 2. Well, that's going to be the same as 2 times 6. Right? It's exact. You should feel smart. I'm glad you feel smart. You guys are so smart and beautiful. It's 12. So I do 6 times 2. That gives me 12. And I do 2 times 6. That also gives me 12. It's the same gosh darn thing, right? The order did not matter. I can move it, and it's still the same. Oh, that's a good question. I said earlier, I don't like to use X's for multiplication, especially because we're doing an algebra course and we're working through that. So later on, we're going to be using X's more freely. And I just think it's silly that we ever use the X for multiplication, when we know that later on we are going to be adding in variables, you know? So I like to just keep it with that dot because the dot never means anything other than multiply. Yeah, learning. I'll give you guys a moment. I know some people like to write these down. My math lives happen every other weekend because I need a weekend off. Aw, I'm glad you exist too, hun. All right. Oh, can we train after? Sure. All right, now I'm going to do what I did last time, and I'm going to write it down in, like, the mathematical definition that you'll, like, see it in a textbook, okay? Happy early birthday. So here's the mathematical definition. Jazz hands. All right. Oh. All right, so where's my thing? I'm doing good. We're doing it. The mathematical definition for this is A plus B is equal to B plus A. All right, these are just variables, right? They're standing in place for some other number. Any number, really. Oh, honestly, we always panic when we see the numbers, like the letters in mathematics, but like, don't panic. I'll tell you what I tell my students. We only panic at the disco, okay? We don't panic in math class. So don't panic when you see those. It's just like a space holder, okay? It's saying, you know, some number goes here, any number, but I'm not going to take my time to think about it right now. We're just going to say, yo, any number. And the reason why we use letters is because it's just easier. It's honestly a simplicity thing on why we use letters to stand in place for a number. Because like, honestly, this could be the Batman symbol for all we care. I could do like Batman symbol plus, I don't know, eraser's scarf. I could draw that every time. Like, it doesn't matter. It's just a lot easier to write A and move on with my life. It's a lot easier to write X and move on with my life than to sit there and be like, I'm gonna draw out the Batman symbol every time. Like, you can, but you'll quickly learn why we do just letters. So that's all it is. It's like if you're standing in line for something and you need to, like, go for a second and you're like, yo, buddy, like, stand in line for me. That's all the letter's doing. It's just pulled into place. All right, so that works. And the other way we can say this is with multiplication. We can do this situation with multiplication. I don't know why I move my hands around so much. It's probably the ADHD. A times B equals B times A. Blop. That also works. And similarly to my last one, I can't do this with subtraction or division. It's a whole thing. What if there was C? It would be the same thing. It'd be the same thing. So this does not work. So sad. They get left out of the party here. New letter just dropped. Subtraction and division are extra. Yeah, you didn't pay for that. They're extra. I'm kidding. But yeah, it does not work. Sorry, there's kind of a glare on my screen right now. For multiplication, for subtraction or division. Well, I'm glad you're here, even though you're in advanced math. This is the start of Algebra 1. These are kind of some warm-up stuff for Algebra 1. We are going to be working through an entire Algebra 1 course together, and you can find it on my YouTube if you ever need it. And we're just kind of starting to work on building that resource for everyone. So once we're done with Algebra 1, we'll move on to geometry, and then we'll move on to Algebra 2, and then we'll move on to trigonometry and calculus, and my gosh, I'll keep this going for as long as you want it. I do have a YouTube. You can look up Thistlewitch on YouTube and you'll find me, or you can go to my page on here, and in my link tree there is a link for my YouTube. Yay! All right, what time are we at? Okay, I think we can slide in the distributive property here quick. We'll do the intro to it, okay? I have thought about Math Lives on Twitch. I just don't have that big of a Twitch following right now, so I reach more people on here. There is also a link to my Twitch if you want to sign up for that in my link tree. All right, let's do it. Now, the book I'm working off of, for like just a pacing guide for this, so that we can make sure we hit all the things. Come on, work with me. Does not put the distributive property here if you look at the same book and want to follow along. But I think they really go together, so we're going to cover it now, okay? Okay. Oh, as I was taking a nap. I mean, my eraser's right here. All right. So does anyone see, similarly to the other words we talked about, does anyone see a word that we could maybe extrapolate some meaning from in the word distributive? Do we see a word we could extrapolate some meaning from? Distribute! Heck yeah, my dears. Heck yeah. You are all so smart and beautiful. Yes, we have the word distribute in there. All right, so if we have the word distribute, what do you think that means for our numbers? What does that mean for us? Anyone have any ideas? Divide, democracy, even out, separate, splitting them into groups. They get passed around like candy. Thank you for the rose. Divorcing them. Oh, moving away, broken apart, to share. Distribute the numbers in an equation. They break up. I love how we're relating these to relationships still. That makes me very happy. That's okay not to know. To give, to multiply. You guys are to fall apart. You guys are so smart and beautiful. I'm loving these. I'm loving your guesses. Oh, they give me life. Distributing, my favorite one in there, I shouldn't say favorite, but the one I like to use a lot because they were all very good. Oh, I'm glad I can make math a little more fun for you. I think math is fun. It just often gets taught in very boring ways. So I'm hoping this helps a little bit. Let's have fun with our math, right? So the one I like to use that I saw in there is like you're passing out candy to your friends. So like picture yourself, you're coming to class, right? And you either have like a bag of chips or a bag of candy, right? And when you enter class with that bag of chips or candy, like everyone swarms, right? If you're an adult, you come into the office with that, everyone's like, what you got there? You got candy? You got chips? That's looking good. Could you maybe I don't know. Could I have some? Right? Like they all swarm. They want some of it. That's the distributive property basically. It's saying, "Hey, I have this and I'm going to distribute it to everyone else." In this case, it's going to be a number, yeah, like gum, that you're passing out to all the other numbers. That's the distributive property. That is the my candy, no share. I know, that's how it feels. It's like, hey, get away. Let's say you're feeling generous that day. It's like that. So let's do an example of what that might look like, okay? Yeah, it's like bringing gum to class, or you got like the mints out, right? Everyone swarms. So we've got, let's say I have 2. We're going to utilize our parentheses again. And let's say I've got 6 plus 1. I'm liking my 6s today, I guess. Oh, well, it's a 6 kind of day. 6 is the number of the day. All right, so here's what we're going to do. Hey, honey. We are going to take that 2 on the outside. We love 6 around here. 6 is a good number. 6 deserves some love today. All right, we are going to take that 2 and we're going to pass it on out to everyone else in this equation, right? We are going to distribute that 2. All right, so I'll actually use a different color for this to kind of show it a little better. Thank you to whoever sent me the lovely markers for this demonstration. We're going to take the 2 and we're going to give it to 6, right? And then we're going to take the 2 and we're going to give it to 1. That's what we're going to do. We're distributing it. All right? So I end up with, what's 2 times 6? 2 times 6 is 12. Nice. plus, because there's a plus, we're just taking that plus down. Nothing fancy there, okay? Nothing fancy there. 2 times 6 gives me 12. 2 times 1 gives me 2. Bam! Oh, and someone already got that answer in the thing for me, and now I can add them together to get my final answer, which is 14. The singing helps. That's all I'm saying. It's not wrong if you don't sing, but it is more right. So 12 plus 2 gives me 14 all day long. And that, my dears, we just distributed. What? Nope, you don't just add the 1. We have to give the 2 to it as well. All right? You gotta hand out a piece of candy to everybody in class. Ooh, math. All right, let's do another example. I'm gonna let you guys try this one, okay? And then we'll do the thing where we write it out again. Okay? Okay. I'm going to give you guys this one, and then I'm going to give you time to do it, okay? Try the distributing. It's like a little cat paws. Oh, I'm going to throw a minus in there. See, now we'll do a plus. I'll be nice. Try this guy. Give this guy a go. And then we will solve it together. Remember to distribute that 3 just like we did above. Beautiful, beautiful, my dears. I love that we're all putting our best guesses forward. It's so beautiful. Because it's way better to guess and be wrong than to not try it at all. Because even if you try it and you get it wrong, you're so much further ahead than everyone who didn't try it at all. All right. Let's talk about it. Talk about it, talk about it. Oh, yeah. I am just actually this character in real life. This isn't an act. Okay. We're going to do 3 times 4, right? And then we'll do 3 times 9. We're going to pass that 3 out to everyone. We're going to distribute that 3. All right, 3 times 4, that gives me 12. 3 times 9, the plus is just coming down, right? Just coming down, nothing fancy there. If it was a minus there, the minus would just come down. That's it. Oh, you're adding. I'm so glad that we're seeing our mistakes. That's beautiful. You're learning so much, and I'm proud of you. Yep, we get 27. 3 times 9 gives me 27. And now we add those numbers. 2 plus 7 is 9. 1 plus 2 is 3. So we get that sweet, sweet 39. Nice. Boop. Wow. You should feel smart. I'm so proud of you. And everyone who tried it and got it wrong, I'm still really proud of you because you put in that effort. And that's the first step towards getting it. It doesn't matter how many times you get it wrong. It matters how many times you keep trying. Okay? Awesome. So we are at the end of our time together here, my dears. So we're going to do that thing where we write down the mathematical definition. Oh, thank you for the applauses. So fitting right now. And then, yeah, we'll write down the definition and then we'll call it a day, okay? And if you missed any part of this lesson, remember you can find it on my YouTube channel later, okay? What am I doing? Here's my eraser. Not my husband, but you know, we'll find him later. It's fine. Okay. We have, again, I'm going to be putting out those letters. Oh, nobody panic. We only panic at the disco. We only panic at the disco. Huh? Right? We took the A and we gave it to all of these things. So it's A times those things.